Hello students, welcome back to the ninth video of this playlist. So in this video, we will be solving question number 9 from the most recent Pure Mathematics 4 past paper, which is October 2024 P4 paper. So let's see what's the question number 9 from this paper is about. So here you go. You can see question number 9 on the screen. So basically the concepts behind this question, it's from integration part of your P4 syllabus. To be more specific, we need to have idea about like how to solve differential equations, and we need to model with differential equations in this question. So the concepts behind these questions are discussed in chapter number 6, that is integration chapter of your P4 textbook. So let's get started with question number 9. So at first, part A. So in part A, they are asking to express 1 over x times twice of x minus 1 in partial fractions. Okay, so converting a fraction, a given fraction, into what? Partial fractions. So what we can say, 1 over x times twice of x minus 1, this is equals to what? A over x plus what? B over twice of x minus 1. Okay, now multiply both sides by x times twice of x minus 1. You will get what? A times twice of x minus 1, okay, plus bx. Fine. So now put x equals to 0 to eliminate b. You will get what? Negative a equals to 1. Okay, so you will get what? A equals to negative 1. Okay, next is put x equals to half to eliminate a. So half, that is 1 minus 1, it's 0, so a got eliminated. So half of b equals to what? 1. So b equals to what? 2. Okay, so 1 over x times twice of x minus 1, it can be written in partial fraction form as what? 2 over twice of x minus 1 minus 1 over what? X. Is this fine? 2 over, yes, 2x minus 1 minus 1 over x. And that's what part A has asked for. Fine. Next is part B. So in part B, the question says the height above ground 8 meters of a carriage on a fairground ride is modeled by the differential equation dh over dt equals 1 over 50 times h times 2h minus 1 cos t over 10. Okay, where t seconds is the time after the start of the ride. Given that at the start of the ride, the carriage is 2.5 meter above what? Ground. So part B is asking to solve the differential equation to show that according to the model, h equals 5 over 10 minus 8 e to the power k sine t over 10, where k is a constant to be what? Found. So we need to solve this differential equation. So for differential equation, the first step is what? To take the terms with h on one side and the terms with t on the other side. So to do that, we have h times twice of h minus 1. So take it to the left side so that dh remains there, and take dt to the right side. Okay, and we will take this h times 2h minus 1 to the what? Left side. This is the first step of differential, solving differential what? Equations. Okay, so for part B, what we are doing, we are taking h times twice of h minus 1 to the left side, so it will come to the denominator, dh remains as it is, and on the right hand side, what remains there? 1 over 50 times cos t over 10, and dt goes there. Okay, so 1 over 50 1 over 50 times cos t over 10 dt. So look, how fine is it? All the terms with h on left side, all the terms with t on the right hand side. Now the second step. Second step is what? Integrate both the sides at the same time. Okay, so 1 over h times 2h minus 1, we just represented it in the form of partial fraction in the previous part a, which can be written as 2 over 2h minus 1, 2 over 2h minus 1 minus 1 over h what? dh. Okay, and take the constant 1 over 50 outside the integral, so you'll get integration of cos t over what? 10 dt. Fine. Okay, let me double check. 2 over 2h minus 1 minus 1 over h. Exactly. Now all about integration. Now integrate 2 over 2h minus 1, it will be what? ln 2h minus 1 modulus. Okay, now reverse chain rule, differentiate the part within the bracket, so you will get 2. Now use this derivative of the part within the modulus to divide the earlier coefficient, which was 2. So 2 over 2 is what? 1. Negative what? It is h inverse, isn't it? H is in the denominator, so it will be ln what? h. Fine. Then you will have what? Plus c, where c is an arbitrary constant, equals to what? 1 over 50. Now integration of cos t over 10, it is what? Nothing but sine t over 10, right? And yeah, it will be sine t over 10, and differentiate the part within the bracket, you will get 1 over 10. So use this 1 over 10 to divide what? The coefficient, which is 1 over 50. So 1 over 50 over 1 over 10, so 10 will get basically multiplied, right? So what we can write? ln 2h minus 1, so take the log ln common, you'll get 2h minus 1 over what? h. Okay, modulus plus c equals to 1 over 5, right? Sine t over 10. Okay, now let's see what's the format the question has asked to show. So they have made h the subject, right? Okay, so we have to make h the subject. So in order to make h the subject, what we can do, let's find out the value of c, the arbitrary constant. How can we do that? A data is given there that when t equals to 0, h is what? 2.5. Okay, so we will use this data, that is when t equals to 0, h is equals to what? 5 over 2. So put t equals to 0 there, you will have what? 2 times 5 over 2, so ln 2 times 5 over 2 is basically 5. 5 minus 1, it is what? 5 minus 1, it is 4 over 5 over 2. Okay, plus c equals to sine 0. Sine 0 degree is what? 0. So it's 0. Okay, so the value for c, the arbitrary constant, it is what? 4 times 2 over 5, so which is negative ln what? 4 times 2, which is 8 over 5. Okay, so you can write this as ln 5 over 8 to make it positive. Okay, so we got the value for c. Now put it in the equation. Okay, so you got ln 2h minus 1 over h, then plus ln 5 over 8. Okay, this is equal to what? 1 over 5 sine t over 10. Okay, let's have a look on the pattern. Let me check whether we are going correct or not. K sine t over 10. Okay, k sine t over 10. Okay, no problem. We have k. We have a coefficient on sine t. So now what we can do? Same ln. You can take ln common again. Okay, they will get multiplied, right? So you will get what? 5 times 2. It is what? 10h minus 5 over what? 8h. Okay, this is equals to 1 over 5 sine t over what? 10. Okay, now what we can do next? We will use the formula for converting logarithm to exponential. Okay, so 10h minus 5 over 8h, this is equals to what? E to the power 1 over 5 sine what? T over 10. Now we just need to make h the subject. Okay, so in order to make h subject, you can simplify it, right? How can we simplify it? We can it can be written as 10h over 8h, which is just what? 5 over 4. Okay, 5 over 4 minus 5 over 8h. Okay, this is equals to e to the power 1 over 5 sine t over what? 10. Okay, so take 5 over 8h to the right side, so you will get 5 over 8h equals to what? 5 over 4 minus e to the power 1 over 5 sine t over 10. Now we can multiply both sides by 8, right? So if you do so, what you will get? 5 over h equals to 10 minus e to the power 1 over 5 sine what? T over 10. Fine. Now we can just invert. We can just invert the fraction. Okay, so if you invert the fraction, what you will get? H over 5. So multiply, take the 5 to the right side, so h will be equal to what? 5 goes in the denominator here. So if 5 goes in the denominator, now after inverting, 5 will be at the top. So 5 divide what? 10 minus it's what? 10 minus e to the power 1 over sine t over 10. Okay, 1 over, is it 1 over 5? We multiplied both sides by 8. So yeah, there's an issue. We multiply both sides by 8, so it will be 5 over 8 equals to 10 minus what? 8. It should be 8. 8 e to the power. Okay, so 10 minus 8 e to the power. Okay, it should be 8 e to the power 1 over 5 sine what? T over 10. That's it. So is it the format what they have asked for? 5 over 10 minus 8 e to the power k sine t over 10. So the value for k is nothing but 1 over 5. Okay, 1 over 5. That's it. And that's what exactly the equation, that is the solution to the differential equation that we found. And that's the end of part B of question number 9. Okay, next is part C. In part C, they are asking to find, according to the model, the time taken for the carriage to reach its maximum height above ground for the what? Third time. Okay, so part C is asking to find the time required for the carriage to reach its maximum height above the ground for the, not first, not second, third time. Okay, so give your answer to the nearest second. Okay, so at the maximum height, okay, since it's the equation, the height above the differential equation that is given here, it represents what? Rate of change of the height, right? So since it's riding So when it will be going up, it will be going up, it will decelerate and it will reach its maximum height, right? So we need to use this concept that when it is moving upward, the carriage should what? Decelerate, and at the maximum height it will reach the rest. Okay, so at maximum height we know that what? Speed is 0, isn't it? Like vertical speed would be what? 0. So we can say at maximum height, what we can say, dh over dt equals to what? 0. So if you consider dh over dt equals to 0, then there are no other terms other than cos t over 10 which can give you the time. The other ones, 2h minus 1 or the 2h minus 1, it can't give you the time, it gives you what? H, the value for the height. So we don't need h. The question asked for the time, so we will consider only what? Cos what? T over 10 equals to what? 0. Okay, so for cos t equals to 0, now we need to use the cast diagram, that we say cast diagram, to get the value for time, okay, at which it is reaching the ground, reaching the not the ground, reaching the maximum height for the third time, right? So consider the graph of cos theta. Okay, the speed of the carriage, it is dependent on the cos theta, the value for the cos theta, isn't it? So the value for cos 0 degree is what? 0, right? Cos 0 degree is 1, right? Maximum value for cos theta. So cos 0 degree is 1, pi over 2 is what? 0. That is 90 degrees 0. Then 180 minus 1, 270, again what? 0. And then 360, again 1, and after 360 it is what? 450. Here it is again 0. Why am I showing you the graph? The reason is that there is a very deep concept lies behind this question. Since the carriage is moving upward, it will be moving upward, it should decelerate to rest. Okay, it should decelerate to rest. That means its vertical velocity should reach to rest when it is decelerating. Okay, so in that case, look, in this part it is decelerating to what? Rest. Okay, but here it is what? It is accelerating to rest, so it's not acceptable. It's not the time when the carriage is reaching its maximum height. Okay, it is not acceptable, because when it reaches its max height, it will decelerate to rest. Okay, so this is what? Pi over 2, and then you got another one. This is what? This is basically pi over 2 plus 2 pi, because this, the two adjacent what point at the x-axis has difference what? Pi. So it is what? 2 pi plus pi over 2, which is 5 over 2 pi. This is for the first time, okay, and this is for the second time. That means the third time would be again after 2 pi radian. That means the value for cos t over 10, which is when it is actually reaching the maximum height, it is basically pi over 2 plus what? 4 pi. Okay, from this point to that point it is what? 2 pi. So again after next 2 pi it will reach the maximum height for the third time, so that's why 4 pi. So what would be the value for t? So 4.5 times 3.1416 times what? Okay, so this is 4.5, isn't it? 4.5 times 3.1416 into 10, so this is 141.372. okay, so 141.372 what? Seconds. Okay, So they wanted to the nearest second, right? So 141 seconds. That's the answer for part C of question number 9. That's it.